Karlberg is a German scientist who used to live in Finland, and they have these very, very long Finnish winters, and they have serious problems without vitamin D. And so he was very, very deep involved doing science in this theme. And he was the first who could show that if you give a group of people the same amount of vitamin D, which is considered as a normal dose, like they gave them 3,200 units of vitamin D, and he could show with his colleagues that giving people such amount of vitamin D, the response is totally different. There are high responses, and he could show that by altering the very, very known proteins who normally be altered by vitamin D. And they have high responses, middle responses, and 25% of the group of students. And later on in a second trial, there were pre-diabetic people. 25% did not respond to this amount of vitamin D on a gene level and on a protein level. And that was the first time in 2015 that they could show that there's kind of vitamin D resistance, like Professor Coimbra, hypothesized years ago from a clinical perspective. And that was a very, very interesting finding, because if you think about all the trials made with vitamin Ds, for example, in the multiple sclerosis, there were many intervention trials. And from the blood serum levels, it looks like they treated them well, but the results were very, very mixed. And if you now consider the fact shown by Karlberg et al., that you have these 25% of non-responses in the trial who do not respond to an average sufficient dose of vitamin D, then if you consider that, then the results would be totally different. In a way that if you consider that fact, then you normally, then you would have much, much better results in these trials. So this is,
I want to interject something here, because you mentioned pre-diabetics not responding as well. There's interesting, I don't know if you're familiar, there's data from early 1920s metabolic study on Greenland Inuit Eskimos, and they looked at vitamin D levels in the development of rickets, which is a deficiency of vitamin D, and they found that the Inuits that were eating their natural native diet, even though they had relatively reduced vitamin D levels, did not exhibit signs of rickets. But if they were now eating a diet that contained sugar and flour and canned goods, even with the same vitamin D levels serum-wise, they would develop signs of rickets. So there could be this background. I'm just wondering, what do you think gives us vitamin D resistance? Are there environmental or nutritional things that may be leading to this potentially?
Yes, of course. Of course, there must be very, very reasons beneath the surface, on a genetic level and on an epigenetic level, who could explain that. Our paper we wrote is mainly on the acquired form of vitamin D resistance. And we explained that later on in the paper, what we mean by acquired and what are the potential agents who could block the vitamin D system. And if you consider the vitamin D receptor, what is it and what does it do? What does it? The vitamin D receptor is a very, very old protein, 100 of million years old. And he is located in the nucleus of a cell and in the cytosol. 20% of it is in the cytosol and 80% in the nucleus. And when the calcitriol is entering the cell, and and then it binds to the vitamin D receptor, then the vitamin D receptor is activated and goes into the nucleus and do some magic things. What does it do in the nucleus? It regulates nearly 2,000 genes as a transcription factor. And that's the the very huge amount of genes, and it's a protein known for the most genes regulating. So the vitamin D receptor, it's a very, very interesting protein, because when it enters the nucleus, it binds to genes which are stored very, very deep in the nucleus. And when I talk to my patients, I explain it like, for example, if you have, well, let me explain. The genes are chromatin, yes? Chromatin strength, yes? Yeah? And we have 46 of those, and they're up to 5 centimeters long. So in this very, very nucleus, we have 46 5-centimeter little strings called chromatin. And on these chromatin are our genes. So there's absolutely no space in this nucleus. So only on the surface are the genes, we need every day. And underneath, are those stored for later things or for things you could not imagine So when, for example, we have a change in temperature from summer to winter, then you need many, many other genes. Or if you have suddenly a disease, you need many, many other genes. And you need something, a protein, who could find those genes. For example, if you think chromatin as spaghetti, if you have a big plate of spaghetti and you have on your spaghetti telephone numbers and very, very little written on your spaghettis. And beneath, there's one number of a very, very old friend from school and you want to call him. Then how could you find these numbers? You need arrows, and you need glasses, and you need light and tools to find on these spaghetti the telephone number. And that's the job the vitamin D receptor does for us. He finds the genes in the nucleus, brings them to the surface, and makes them readable. And so the regulation could kick in. Without such a transcription factor, cells are not able to make their genes readable. And the VDR is doing it for 2,000 genes. And what are these genes? They're genes about nutrition uptake. Yes. Genes about the integrity of your intestinal barriers, like leaky gut. Without vitamin D, the cells could not glue together, for example. And very unknown fact is vitamin D is involved in detoxification via the bile acids. That's a very, very old mechanism to get rid of toxins. And without vitamin D, it does not function very well. And of course, there is this immune system where vitamin D plays its action. And in case of an autoimmune illness, you need to know that Carlberg showed with his work that the HLA cluster in immune cells, and to explain to the audience, on the HLA clusters is the information for the immune cell to recognize our own tissue and to differentiate it from foreign invaders, from antigens. So these HLA clusters and every immune cell needs to have this book open and readable. Without, they're blind and they do not know which or who to attack. And vitamin D opens the HLA clusters. And there are a few clusters, and vitamin D is the only substance known to open these HLA clusters. So without vitamin D, it is possible that your immune system is totally blind and could not recognize your own tissue and mixed it like it's normal for an autoimmune immunity or autoimmune disease. So that's why the vitamin D receptor is so potent and so serious in autoimmune disease. What we show in our paper is the evidence in the literature that these vitamin D receptor could be blocked, easily blocked. And from an evolutionary perspective, it's very, very reasonable that it could be blocked because it's more 400 or 500 million years old, the vitamin D receptor. So in evolution, microbes need to find a way to evade our immune system. And why not take such a potent receptor like the vitamin D receptor?